So welcome to the presentation of my proposal, Digital Preservation and Restoration of Indian Cultural Heritage. I am Shanmuga. I am a faculty member at Indian Institute of Technology, Gandhinagar, and here is my teammates. The first one is Sashikant Verma, who is a PhD student, and Kaustup Sadekar, who is a senior research fellow, and Meet Panchal, who is a junior research fellow. These are the guys who are working in this project with me. And in this project, the main problem we address is on restoring the cultural heritage artifacts using AI and computer vision, 3D computer vision technologies. So the three main steps involved in the project are the 3D scanning and processing technology and some post-processing algorithms which we use, and also some of the AI tools which we use to restore the monuments and display them in the 3D web. So there are the three main basket of things involved in this project. The first basket involved three different steps. One is the 3D scanning and pipeline to get the physical artifacts to the digital world and then process them. And then if there are some broken parts, we have our own tools to restore them and then make them identical to the undeformed replica of that artifact or the monument. And the third step is to provide platforms to view the artifacts and also digitally and also 3D print them. So for creating replicas of the same monuments at a scaled down version and so on. The second aspect is how we want to convey this kind of work to the world, right? So that also involves some three different steps, three different heads. So one is the web platform through which we can show the artifacts and monuments to the thing using an interactive web platform. The way we want to envisage this project is how it can be of value to different end users. So some of the applications which would be addressed are game developers and robotic navigation researchers who would be very interested in getting a virtual walkthrough and use it in their own projects. And the next one is we can create digital replicas and show the monuments and artifacts. Another is a virtual walkthrough also we can create and show the monuments where we want to navigate virtually. And the other commercial aspects include we want to give consultancy to various government agencies advice regarding the kind of work we have been doing, and also organize courses and workshops to different stakeholders such as industry professionals, academics and archaeologists, museum curators and others in order to enlighten them about the kind of state-of-the-art work in this area. So the uniqueness of the work lies in kind of merging of the terrestrial laser scanner and the small laser scanner for handheld laser scanner for scanning small objects, as well as using just images to create the 3D thing. So there are multiple modalities through which you can reconstruct a 3D space. So we are giving all the solutions based on these three modalities: terrestrial laser scanners, handheld laser scanner, as well as images. And also we have a complete restoration framework, and we work in particular in the Indian context to make an impact. And also we believe that the kind of artificial intelligence and deep learning based algorithms which we have developed to process the shapes and then kind of get the best results, and we have our own in-house algorithms which make it very unique.
Hello, I am Sashikant Verma, a PhD scholar at IIT Gandhinagar. Today we are in front of Lal Minar, and I am going to showcase the 3D acquisition process using the Faro TLS laser scanner.
This kind of scanning could be extrapolated to any large-scale structures in any part of India, so that we are restricting our illustration to the Lal Minar for just a purpose. And as you can see, the entire Lal Minar could be captured by few positions. You keep the laser scanner, the terrestrial laser scanner, and the terrestrial laser scanner also has a range up to 330 meter, which makes it very comfortable for the end user to scan any structures which are very lengthy or which are far away from the place where you can ideally place the laser scanners.
To scan small objects, we use structured light scanner. Here we demonstrate the setup to scan this bone using Einscan Pro Plus scanner. After post-processing of the acquired 3D information using computer graphics tool, we store the content digitally in form of meshes, point clouds, etc. The processed data can then be 3D printed or viewed digitally as per the requirements. Here we show some of the artifacts scanned from the museums, 3D printed.
Apart from the 3D scanners, we also have the facility to reconstruct 3D objects simply using multiple images of the object from different viewpoints. This process is called photogrammetry. For photogrammetry, we use an open source software called Meshroom. Using this method, we are able to reconstruct dense 3D models with accurate texture information. Here, we show a dense 3D model of a pillar at Rani Ki Vav.
Of all the scanned objects and sites, we have created an online web repository where the scanned data can be viewed and analyzed. We also provide interactive tools for the analysis of the scans and sites.
So the technology readiness level of the work we have done, we can categorize the work into four different heads. So first is the 3D scanning algorithms, where we have achieved maximum expertise and we are expecting it to be of technology readiness level 7, so which is directly we can just with some minor tweaks we can take it to the market. So, and the next one is the photogrammetry kind of pipeline, where we take multiple images to reconstruct the 3D model. So there we have readily available algorithms and everything, but depending on the platform we want to port, we need some customization, so we place it at technology readiness level 4. And the third one is the 3D restoration kind of algorithms and the processing algorithms, shape analysis algorithms, which we have developed in our lab. So that is also like kind of we are almost there, and we have all the algorithms ready, but still we need some customization depending on the application we need. So there is a web-based 3D interactive visualization tool we have customized for virtual viewing of these artifacts and these monuments. So that also is done, but this is also will place in technology readiness level 4, but still some customization may be needed depending on the end user requirement and everything, so that it suits the needs of the customer based on the sizes of the object, the complexity and the geometry of the object, and so on. So the primary stakeholders who would be interested in our project and take it further would be, the first one would be an archaeologist. So they are very much interested in digitizing, because the sites are very far away from the city, they cannot reach, and the virtual digital model would help them plan the excavation in future and so on. And also some surveying industry people may be interested in civil engineering, where they can scan an existing site and or structure and try to digitally manipulate and for the future renovation and kind of work. And also some disaster management kind of rescue operations. So if you have digitized some of the complicated landscapes in India, so they can plan if some kind of a disaster occurs, so how to enter, where to go, and those kind of planning could be done virtually. So another class of industries who would be interested in gaming industry. So they want to create new games with some cultural heritage monument as a backdrop. So for someone, some player enters into some tunnel and does something. So those kind of things could be planned by the gaming industry. And also VFX and content creators also would be interested in this. And another kind of people who would be interested in the robotics. So the robotics data sets, you can easily create some new standard data sets for robotics kind of virtual navigation, like SLAM and other things could be virtually checked whether they are working, and the robotic interactions, those could be modeled using the digitized structure we are providing. And the final thing is for the educational purpose, so where we had foreseeing some museum curators who would be interested in hosting some of our artifacts virtually, as well as the replicas which we print using a 3D printer, and to educate people and increase their collection with the minimum cost. And these are some of the research communications, some of the journal articles and conference papers which we have published as a part of this research work. And acknowledgements include the funding agency SERB Imprint to Grant, IIT Gandhinagar and Jiba Ben Patel Chair, and also the Archaeological Survey of India, which gave us access to sites such as Dholavira, Lothal, Dwarka and Rani Ki Vav and many other sites. So these are the things I could think of. So, but I would be very happy to interact with other domain of experts from industry and government agencies to see where the work we have done thus far could be taken further and can be of maximum benefit to different stakeholders. Thank you.